Hello, welcome to this coding vlog. I think that's what we call it. Devlog, that's what I meant. In Unity, where I'm making this VR application. And as you see, it's fairly well along at the moment in terms of having an infinite Perlin terrain, various locomotion modes such as jet jumping, I'm calling it, which is really good fun if you're if you do something like that when you're in a VR headset. It's really good fun. Anyway, what I'm developing at the moment is to do with this little pink circle here. Let's just come into a different mode. Right, we're in fly mode. So this little pink sphere is controlled by a script that is just shooting out a physics ray, a raycast, and then when we hit a surface, something with a collider in front of us, then we position the sphere at that point of impact. And the idea is that I'm basically creating another locomotive mode. Let's just come out of flight here. Yeah, you'll notice that I'm like tilting my head and things like that. That's because obviously when you're in a VR headset, I want to cater for headsets that don't have controllers. So I just spit this out as an Android app, which I'll put onto the Play Store if anyone's interested. I will do eventually. And so I just wanted anyone to be able to use it. If you've got, as long as you're Android, then use it with your mobile phone. Just bang it in like a cardboard app or any kind of like headset, and you'll get like a really good experience. I've got two like headsets. One is a cardboard and it works really well. It's a really good fun experience in there. So what I want to happen, so I've got walking around, working. You can drive. Here we go. Ooh. I call this a rumble sledge. I'm going to sneeze in a moment. You can. Oh, excuse me. Oh, we're going to crash. It's alright. I saved everyone. So we can drive around, we can walk, we can kind of like fly. But I want to be able to do what Spider-Man can do. And have you ever seen Attack on Titan? The kind of, what do they call them? Omnidirectional gear or something like that? OM gear or OMGs or something? I don't know. So it's where what I'm planning on doing is wherever this sphere lands on whatever surface, to create like a line or rope from our position to the sphere's position, and then we like zip line up to that position, and then we want to be able to use our head to like fire a line, and then a tilt to maybe cut the line, so you can like fire it and then kind of like glide from that position of being swung towards a certain vector or whatever, and then and then basically every time we tilt the head left, I guess, then we want to glitching. Oh, I found some glitching there. At least it was on camera. Anyway, right. Right, so what have I got in what's going on in here? So I want to go for about 33 minutes ish. Has it been about 5 minutes now? I don't know. So I want to go into about, let's call it 9:10, and then I'll stop and then make another video if it feels right. Right, okay, so so there's our subject, and then I've got this sphere object. Right, so it's actually just a sphere, and I've applied this Toon Basic Outline shader. I think you can get the Toon shader from Standard Assets. You can download that for free. Unity have made it. And then I've just started creating the script for it. So I want the script to be attached to this object external to, I call it the subject, the player, so that I can keep things tidy. I could then, any kind of player controller thing in any other simulation or game, you could just drag this prefab in and then assign who your player or your subject is, and then it'll like kind of start working. So that's how I want to organize things. Anyway, so we've got two public variables. we've got a transform, that's our subject. So I guess that's going to be useful because we want to kinematically kind of move, translate the player's position along that trajectory that we kind of work out when we tilt our head when the sphere is touching an object that we want to swing to. It could be a tree, could be a rock, could be a building, something like that. And then we've got a main camera, so that's actually inside the subject. It's a first-person perspective, and it's here, yeah, the main camera. So that's wherever the player is kind of like looking in with their headset on. Oh, I could also make this into just a normal like mobile app, kind of like that international sign for playing on your mobile phone in landscape. I could do that, but I'm I'm really bad at steer rotations and things. I got it working in another thing, and then anyway. If people want it, that's what I'll bring to the people. Anyway, so inside our script, I'm calling it silk line. I call this system silking because I imagine the line's made of, I don't know, like a future nanotechnology that's to do with silk. I don't know. But the line's presumably got to be pretty strong. So there's our public transform variable, my subject, and the camera variable that we were looking at on the script in the editor. I might make the... Is that too big? Maybe that big for our code so everyone can see. And that's it so far. Less than 27 lines. So start game object layer equals 2. Right. So... What initially happened was when this game object, the sphere thing itself, we are shooting a raycast from the player's position, and what would happen is that that cast would hit the back of the sphere itself, and then in the script we say the position of this sphere equals the hit point, basically. So we were just hitting ourselves and then placing the ball behind it so that the sphere would just gradually move towards the player. Let me just show you that bug, and then it'll make sense if my explanation didn't. So the application begins in walk mode, and auto walk, no, is it? No, you're just standing around, I think. So you have to tilt the head right to like precisely move around. Sorry, it's taking a little while to load up. Okay. Wow. So did you see the problem? It was kind of hitting itself, and then it managed to smash the player to glitch world. There we are. I can't believe this. Glitch world twice in like so many minutes. There you go. You know what I could do? I could say like when the player position is below a certain amount, teleport you back or something, wouldn't it? Right. So to overcome that bug, we're saying the sphere's layer is 2. Where can I show you layers? I think it's in here in the project settings. Physics. It'll be under. Are these the layers? Yeah, I think these are layers. 2 is transparent, I think, FX. Oh no, it's obviously ignore raycast. So 0 will be UI or default or something, I don't know. Layer 2 is ignore raycast. So the ray, when we shoot it here in the update function, is going to go straight through the sphere's collider. Okay. Actually, have we even got a collider on it? Yeah. Do we need a collider on this thing? Let's have a look. We really probably don't. I think it was initially when I tested it out, we wanted the ball to kind of, or the sphere to kind of like sit on top of the landscape, but now we're kind of directing that physics kinematically, i.e. through translations and things. Oh, there's a little alien. Okay, so that works fine. So we don't need the collider. I might take that off altogether. Sometimes colliders, even when they're disabled, they can have some functionality or something sometimes, because that can be useful. I can't think of an example to explain, but there you go. Right. Okay, so this is the physics raycast. Basically, we're saying if we shoot a ray from our camera's position, excuse me, in the direction, that the camera is facing forward, and we can go 1,290 units. I think that's kind of like the limit of the camera's what do you call it? Maximum distance that it can see. Then, so if we hit something, then the sphere's transform position will equal the hit point minus. We're bringing it back along the vector of the camera's like looking. So it's coming back along the direction, the trajectory that your camera is looking. Back 1.2 units. Yeah. Okay, so that just lifts it. Sorry, the reason I'm doing that is it lifts the sphere out of the object that it's touching, so it doesn't kind of like disappear or half disappear into the wall or something. I want it just to sit as a sphere on the side of the wall. So this number really should be relative to the sphere's size. So I could change that now. Let's do some actual coding. So it's this transforms lossy scale or local scale, dot any direction, because it is a sphere. Let's just pick Z. There we go. Save that, and let's just save everything. Do you also get like OCD over like saving stuff? Like I have to save that and save that and then save it again. I don't know. Especially with Unity. How are we doing for time? Maybe about, what did I say, 10 past? So I've got 15 minutes. Next step will be, yeah, when we're loading like this, I should talk about next step. Next step, I'm going to actually start moving the player. I've got an idea that we kind of want to let's put auto walk on. We kind of want to increase the drag on the physics of our play, of our subject, so that we move more like we're moving through water. That's something I've done when I've done a similar system to this in a previous project. Just helps with how we're moving through the air. Okay, this isn't too bad. I could fiddle around with this. Okay, so it is lifting it out of the ground slightly. Let's just, I don't know, times 2. I'm sure I need to use pi or something for this, to do with the area, or the volume of a sphere or something. Let's just look at that again, and while it's loading, let's talk about our plan. So next step, let's just, we need a bool. We need true or false. If the user does that, if they tilt their head, then we want to turn on, I'll call it silking. So it's true that we are silking. And then we just want to move them towards, yeah. Okay, that's sitting a bit more on top of objects and things. I kind of like that. That's nicer. That's nicer. Okay, I'm going to actually change that to pi. Can I just write pi? And let's make a const here. Private const pi equals 3.142. What's going on here? Why can't I do that? Private const float. I can't even remember how to declare a const. There we go. Lovely. Now I can just write pi there. That should be fine. Right. Once again, I've just got to check that. Yeah, so first thing, fiddly thing I've got to do is go and copy and paste some code that I've written already for tilting the head around. That will be on the locomotion script of the subject. That should be fairly easy. Wow. Okay, good job we checked that. Pi is too much. That's uncomfortable. So we've got a bug there. So basically the sphere gets too close to us. Okay, if the sphere gets too close, then we need like a, I don't know, like a restriction. Leave pi in there. Let's say, this will take like a physics calculation. So I don't know whether to actually do it or not, or just would it be? Oh, I don't want to waste my const now. Right, I'm just gonna put 1. No. Did I have 2 before? I don't know. 1. We'll just put 1. No, we don't have to do that because, yeah. Right. Goodbye pi. Oh, such a shame. That problem could occur anyway, but it's more optimal in terms of the code running that we don't do vector maths as we do vector maths as least as possible, as few times as possible. Right, so in our location script, we want to go and get some code that just detects whether we're tilting our head. So I've already written that, and I want to keep it constant to the degree by which we tilt the head for location. So anyway, let's have a look. Jet toggle, there we go. Right. So Z rotation. Oh, and we're going to need to start. Yeah, okay. That. And where do I declare Z rotation? You know what? I'm going to try and do that myself. Right. So, we're going to write ourselves a check. I'll call it toggle. Write ourselves a function. It's not going to return anything, so it's void check toggle. Oops. And we need Z rotation. That's going to be a float. Z rotation equals my cameras dot transform dot rotation. Can I just get Euler angles? Almost said Euler angles. Euler angles dot. It's on the Z axis, isn't it? Z There we go. So there, I've got the rotation of our head on the z-axis, so tilting your head like that, moving your ear to your shoulder, in Euler angles, so not quaternions. Usually a rotation is stored as a quaternion, which is like a way of doing rotations in 3 dimensions very smoothly. And an Euler angle converts to a nice floating point number for me. Okay. So I'm saying if I've tilted my head, it's going less than 30 degrees, more than 20, and time times that minus timestamp is greater than 3 seconds, so you can only do it every 3 seconds. What might be better is every half a second. Else, if you tilt, if your head is in the right position, then it's just going to throw a silk line every frame, which we don't want. We only want it every 0.5 seconds or so. You know what, I'll put it onto 1 second and then speed it up. I'll tune it up later. Right, so we also need a timestamp here. Will that need to be public? Not public, kind of like globally scoped to the script. Yeah, I think so. Right, private timestamp, and it's a float. Let's actually write a comment for keeping track of rate of silk line throwing. And let's give that timestamp a value, real time since startup, in seconds, I think. No, or something. Yeah, I think that's in seconds. And then what we're saying, when we're going to check toggle, let's just comment this as well. Subject wants to throw a silk line. Position silk sphere. So maybe we don't want to position the silk sphere when we're, oh, we do want to position it when we're silking along, because you might want to, you're silking up a tree and then you want to go over to that tree over there, so you want to be able to use that sphere. So that always wants to be kind of like running. Check toggle. Okay, have we turned our head enough? Then yes. So if the answer is yes, then we want to reset the timestamp. So we want to say timestamp equals now, which is what we've just written up there, real time since startup. So what we're asking is the current time minus the timestamp greater than 1 second? So is a difference between the time now and the last time we timestamped, is a difference between those greater than 1 second? In other words, has 1 second passed, then we'll run this. And it's important to stamp the time now again, so that we can ask this question meaningfully again next time round. So here we want to say silking is on. Silking equals true. So switch on silking mode, silking process, should I call it? Switch on silking process. State, it's more like a state. Oh. Oh god. I'm just randomly hitting keys here, changing the volume. Troom. Then I was thinking of Donald Trump, I think. Weird. Right, switch on silking mode. So I'll switch on the silking mode. Also, we want to kind of clamp and record where our sphere is. So the anchor point, I guess. Anchor point equals transform. This transforms position. There we go. So if we're looking around and the sphere is like changing position, our anchor point will stay the same to what we've kind of like picked with the tilt of our head. Okay. That's about it. And then in update then, we want to say if in silking state, then move the subject accordingly. I'll call that on the pattern of our other function. We'll call it check silking. I'm just going to add those variables that we need. What is it? What did I say? Silking equals false. That's a bool. I keep forgetting types for some reason. Private, what was it? Anchor point. That's going to be a position, so that's a vector 3. Vector 3 anchor point. And we'll just say equals vector 3 0. I think Unity have got built in what we call that, something or other. Oh, I've got 1 minute to go. So it's not liking that for some reason. I'm sure that's fine. Okay, anchor point, lovely. And now let's just write our final function here, void check silking, and here we want to say if we're silking, then do this. So what we want to do is move the player up that line. So I want to say something like subject, or my subject dot, oh, it is a transform already, so we can go straight to the translate function, and here we want to say which direction. So we'll call it trajectory, or traj times, and it kind of wants to accelerate, I guess. So silk speed, there we go. We also want to say silk speed plus equals acceleration, and then if silk speed is greater or equal to max speed, should I put this in fixed update? Since we're doing some things that will affect physics now. So that wants to be time dot delta time. That's to smooth it across different computational times, i.e. if you've got faster or slower mobile phone, it'll run the same on all of them, unless we're losing frame rates. Trajectory times silk speed times time dot delta time silk speed greater or equal to max speed silk speed equals max speed. You know what? I don't like that greater than max speed. Let's just put that. Right, so we need, the most important thing that we've got to work out is our trajectory. And we don't want to calculate that here, we want to calculate it once in check silking. I've noticed I've run out of time now, so do I carry on? You know what? I'll finish it here, I'll stop here, the video, I'll actually stop, and then, yeah, make part 2, where, I'll have to not do any, I'll have to do, okay, sorry, I just stopped talking, thanks very much for watching, see you in the next video to see if this actually works, there we go, and we can like jump around and stuff, goodbye.